We have been learning about the set operations complement, intersection, and union, and applying these to Venn diagrams. We're going to take those same basic operations and apply them to Venn diagrams with 3 sets. Now, before we do that, let's quickly review applying these to 2-circle Venn diagrams. In example 1, we're going to use the given Venn diagram to find the requested sets and express these sets in roster or list notation. Looking at the Venn diagram, we need to find A intersect B. Now remember, we're looking for sets that are common to both A and B, or the overlap of the 2 circles. So we've got 2 elements there. Those are elements 4 and 5. Next, we want to find A intersect B complement. Now, A intersect B is the shaded region, so the complement is going to be everything outside the shaded region. So this would contain elements 1, 2, 3, 6, 7, and 8, 0, and 9. I want to put these in order, so I'm going to sneak back over here and put 0 in front. So everything except 4 and 5. Next, let's identify the elements in A complement. So remember, we're looking for all of the elements outside of circle A. So I'm looking for everything in the shaded region that remains outside of circle A. This would contain elements 0, 6, 7, 8, and 9. Feel free to use the shading technique to help you to identify those different regions of your Venn diagram. So for example, on B complement, I'm looking for everything outside of circle B. So anything that remains outside that circle, I'm going to contain in this set. This includes 0, 1, 2, 3, and 9. Finally, let's look at A complement intersect B complement. Now remember, we need to know the elements in this set, and we need to know the elements in this set in order that we can find out what they have in common. So I'm going to look at set A complement that we've already found and set B complement and just inspect them element by element and identify the common elements. So we can see that 0 is in common and 9. Did I get them all? 0 and 9. Now, even though the next example looks a little bit complicated, it's A complement, intersect B complement, complement. What I want you to recognize is A complement, intersect B complement. That is what we just found. That contains elements 0 and 9. So the complement of that is going to be everything except 0 and 9. So that's going to contain digits 1 through 8. Okay, now we're building up to these problems. Should you run into this question on the homework without any previous questions, find out what's in A complement, what's in B complement, what do they have in common, and then you can figure out the complement of that set. So approach it little by little. How about the next one? You remember this? What is A intersect the empty set? What do A and the empty set have in common? Nothing. So any set intersected with the empty set is the empty set, and we could say the very same thing for this one. Okay, that's where we've been. That's what we've learned so far. Let's apply these same skills to a 3-circle Venn diagram. Example 2, the different regions of a 3-circle Venn diagram are labeled with Roman numerals. Identify the regions represented by each requested set. So this one's a little bit different. We've got 3 circles, sets A, B, and C. And instead of listing the individual elements of those sets, we have the regions represented. So for example, region 1 represents the space that is inside circle A, but outside circle B and outside circle C. The next region, number 2, represents elements that are in both circles A and B but are outside circle C. Okay, so let's use that strategy to identify the regions described by circle C. Well, I'm just going to identify all of the regions that are within that circle, and we're not doing roster notation, we're just identifying regions here. So this would be 4, 5, 6, and 7. Okay, so again, I'm just looking at all of the regions inside circle C. Next example, B union C. So in this case, I'm looking for all of the regions in circle B and circle C together. So this would contain regions 2, 3, 4, 5, 6, and 7. Next, A intersect C. So I'm looking for the overlap or what A and C have in common. So circles A and C intersect right here, and that would be regions 4 and 5. To find B complement, I want to list all of the regions outside circle B. So another way to do this other than shading, take your thumb, cover up everything that you see in circle B and list everything outside of circle B. This would be regions 1, 4, 7, and don't forget the one out there in the universal set, 8. Okay, A union B complement. First, let's identify A union B. A union B is everything in circle A together with everything in circle B. Now, take your fingers, cover up everything in those two circles. What you see remaining is the complement, right? Everything outside of circles A and B. We would end up with 7 and 8. Okay? Next, we have A intersect B complement. Well, let's figure out first A intersect B. A intersect B represents the region that A and B have in common. The complement of that set is everything except what's in the shaded region. So cover up the shaded region and list the regions outside. We have regions 1, 3, 4, 6, 7, and 8. Okay, doing good so far. Now, we've learned intersection. Let's apply it to 3 sets. We want to find A intersect B intersect C. That means all of the elements that are common to all 3 circles at the same time. All 3 circles share that inner region in common, so that would be region 5 only. Okay, let's try the next one. B union C intersected with A intersect C. Now, in order to find this intersection, I need to know what regions are in B union C, and we've already done that. We have found B union C over here. I also need to know the regions that are in A intersect C, and we have that done here as well. Now I'm going to figure out what regions are in common to both of those sets. So I'm going to compare those 2 regions and identify what's in common. Looks like 4 is in common and 5 is in common. Okay? If you run into a problem on your homework that looks like this, figure out what elements or what regions are represented by this set on the left, find out the regions on this set, just like we did, and then find out what they have in common. So the rules that we have learned also apply to 3-circle Venn diagrams. It's just more information to think about. Let's try another example. Example 3, use the Venn diagram to find the requested sets and express the sets in roster notation. So it's the same idea, but now instead of identifying regions, we're going to be listing individual elements. So the first thing we want to find here is A intersect B intersect C. That's going to be what all 3 of those circles have in common. Complement, right? So I'm going to find everything except what all 3 have in common. So I'm going to list everything that is not in the shaded region. In order to have room, I'm going to write it down below here. So really, I need to list all the numbers 1 through 13 except for 6. So we have elements 1, 2, 3, 4, 5. Remember, we're not listing 6, 7, 8, 9, 10, 11, 12, and 13. Next, we'll find all of the elements in B complement. So I'm going to look at circle B. Then I'm going to cover up all of those elements with my thumb or with my hand, and I'm going to list everything outside of circle B. We end up with 1, 2, 3, 7, 8, 12, and 13. Next, let's find A union B complement. Now, circle A, I'm going to do a little bit of side work here. Circle A has elements 1, 2, 3, 4, 5, 6, 7, and 8. And B complement we have listed right here. So I want to take everything in A and unite it with everything in B complement. So I'm going to unite these two sets or merge these two sets. We have 1, 2, 3, 4, 5, 6, 7, 8, 12, and 13. Next, we're going to find A union B complement intersect C. A union B complement we already found right here. So now I want to figure out what does that set have in common with set C. Well, I need to see what C looks like. So I'm going to list it out here. If you don't want to list it, you don't have to. In fact, let's just use our Venn diagram. Here is set C, right? So I'm going to figure out all of the elements from the set we just found, all of these, and compare it to all of the elements in C and see what they have in common. So it looks like we have, let's see, 1, 2, 3, 4, 5, 6 is in common, 7, 8, and 12. Okay, so pay attention to your signs. Which direction? Is it a union or is it an intersection? And also, we need to pay attention to that symbol right there. Remember, that represents cardinal number. So instead of listing the individual elements of the set, I'm counting the elements. So this problem says find the cardinal number of A intersect B intersect C complement. Now remember, over here, we found A intersect B intersect C complement. I want the cardinal number of that set. So I'm just going to count the number of elements in that set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. So the cardinal number of that set is 12. Similarly, if we want to find the cardinal number of B complement, I just need to count the elements in B complement. That's 1, 2, 3, 4, 5, 6, 7. So there are 7 elements there. The cardinal number of A union B complement would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the cardinal number of A union B complement intersect C, this is not too bad because remember we've already listed the set over here, so we just count the elements. 1, 2, 3, 4. Cardinal number is 4. So watch closely for the direction of your sign. Is it intersection? Is it union? If there is no little n, no cardinal number, you're actually listing the individual elements in roster notation. If there's an n, that just means we are counting the number of elements in that set. So that's not new information. It's simply applying the rules that we've already learned to Venn diagrams with 3 sets. Now, let's try an example where we actually have to construct the Venn diagram ourselves. So we have our universal set, set A, B, and C. And then we're going to find those sets and list them in roster notation. Really helps to draw a Venn diagram and organize your information first, and then use that as a tool to answer the question. Notice we have 3 subsets, A, B, and C. So we're going to need 3 overlapping circles, A, B, and C. So we're going to call this A, B, and C. Now, I want to work my way from the innermost region out. The innermost region is going to identify what A, B, and C all have in common. So I'm going to look at all of those sets and identify the common elements. Notice all 3 of those sets have a 2. Let's see, what else? I think that is it, right? So we're going to put 2 right there in the innermost region. Now let's work our way out. Let's figure out what A and B have in common. Now, just comparing these two sets, they have a 2 in common, but 2 is already accounted for in the innermost region. We can also see that A and B have a 5 in common, so we're going to put that outside of circle C. Next, let's compare circles A and C. Let me change colors here. I'm going to look at set A and set C and find out what they have in common other than 2. Notice A and C both have a 3. A and C both have a 4. So the 3 and the 4 are in common to A and C, but they are outside of circle B. Next, let's work on the region B intersect C, but staying outside of circle A. So looking at sets B and C, determining what they have in common, there's a 6 in common, and that's it. Okay, now we're going to finish off our Venn diagram by listing all of our elements in circle A that are left. Notice in circle A, we have a 1 left. Now, very quickly, A has elements 1, 2, 3, 4, and 5, and I can see that all of those are accounted for on the Venn diagram. Looking at circle B, leftover elements are 1 and 8. So those are going to go in B alone. And finally, C has a 7 left over, so it's going to go out here in C. The last thing I need to check is to make sure we've used everything in the universal set. The universal set contains the values 1 through 9. So I'm going to look at my Venn diagram, and I notice, did you notice I have a mistake on the Venn diagram? Let's correct that very quickly. A and B have a 1 in common. Did you see that? Let's move that 1 into the intersection. Glad I was looking over that. Okay, so we have values 1, 2, 3, 4, 5, 6, 7, and 8 on our Venn diagram. 9 has not yet been accounted for, so let's move the 9 out here in the universal set. Now we're ready to determine the sets. Question A, we need to find A union B union C. Now let's start with B union C. Let's figure out the elements in B and C. So I'm going to take all of the elements in B together with all of the elements in C. That's going to give us 1, 2, 3, 4, 5, 6, and 7. All of B and also 8 here on the end. All of B together with all of C. Then I'm going to unite this with A. Well, A doesn't have anything additional to add because notice the part of the circle that is A only doesn't have any elements. So we end up with 1, 2, 3, 4, 5, 6, 7, and 8. Let's try the next one. A union B intersect A union C. Let's take it a little at a time. Let's first determine A union B. So everything in circle A together with everything in circle B. We have 1, 2, 3, 4, 5, 6, and 8. So that's everything in A together with everything in B. Now let's look at A union C. Everything in A together with everything in C. So I'm just looking at the regions inside circles A and C. That's 1, 2, 3, 4, 5, 6, and 7. Now I want to find the intersection of those two sets. So I'm going to compare these two sets and determine what they have in common. Looks like we have 1, 2, 3, 4, 5, and 6. So we end up with 1, 2, 3, 4, 5, and 6 for our big set. Okay, so take it a little at a time, break it down one set at a time. Next, we have A intersect B union C complement. So to figure this one out, I need to know, first of all, what is in C complement. So I'm looking at the Venn diagram, and I'm going to list all of the elements outside of circle C. That would be 1, 5, 8, and 9. Then I'm going to unite the set we just found with circle B. So everything in this set together with everything in circle B. So B union C complement. looks like 1, 2, 5, 6, 8, and 9. Now that I know this set over here, I can now figure out what it has in common with A. So I'm going to look at the set we just found and compare it either against the Venn diagram, all of the elements inside circle A, or against the listing up here. And I'm identifying the intersection, what elements there are in common. So it looks like we have a 1, 2, not 3, not 4, 5, and not 6, 8, or 9. So we end up with the result. So again, break these down into smaller problems and you can build up to those bigger questions.